Thanks for joining me today. We're going to be going through a case study of the TransportHealth Module 1. And just as a bit of an overview of what we're doing with TransportHealth, these are the many steps that go into completing a transportability analysis. So first, we want to start with stakeholder engagement and applying causal reasoning using directed acyclic graphs or DAGs to identify relevant confounders and effect modifiers. And this would be based on engagement with clinical and other experts, as well as usually a review of the literature. Then we would identify our source and target study data. We would curate that data to make sure that the data is clean, that the relevant variables are available, and data is harmonized between data sets. For the purpose of this tutorial, we're going to be focusing on how to do this analysis using the TransportHealth package. So we're going to skip those first 3 steps and assume that you've already done them, and instead focus just on that component. How do we use the TransportHealth package to run transportability analyses? And in this case, we're going to start with an illustrative case study using weighting-based transportability analysis. And weighting-based transportability analysis is the most commonly used analytic method. So you can see here, the green is the proportion of all published transportability and generalizability analyses that use weighting-based approaches. And in terms of what's required to do this from a data perspective, we need individual level data in the source population. So that would be the study that we're starting with. And then we also need individual level data in the target population. So that's the population you want to transport the study results to. From privacy, when we consider this from a privacy perspective, we need both these data sets to be mergeable. So one person needs to be able to have access to both data sets. So just to set up our case study, we're interested in the effects of an antihypertensive treatment or medication on systolic blood pressure. So our treatment variable is going to be that antihypertensive medication, and our outcome variable is going to be systolic blood pressure. And we're curious about what its impact is relative to the standard of care in our local population. We have the following data. So first, we have individual level data from observational study conducted in the United States, which includes information on the treatment that each patient receives, their blood pressure, and then some other individual characteristics that might be related to treatment response. We also have another data set, which is our routinely collected individual level data from our local population, and that includes those same characteristics, but we don't have data on what treatment they received or their blood pressure. And the goal of this case study is to estimate the effects of treatment on blood pressure in our local population. So just to go over the relationships here, you can see on the right-hand side of the screen, we have a DAG of the different variables involved in our analysis. And you can see we have treatment down here, that's our antihypertensive treatment, and next to it we have blood pressure, and that's our outcome. The rest of these are covariates and effect modifiers that we want to include, as well as study participation, which is a key component in transportability analysis. If you want more on that, you can go back to the introductory video on transportability analysis, where we talk a little bit more about the role of study participation in these analyses. In this study, or this case study, we're going to adjust for sex, percent body fat, and stress level as covariates that are potential confounders. And then we've identified stress level and aspirin usage, or MED2 in this data set, as our effect modifiers that we want to adjust for. And just as an overview of the data sets and variables, we'll have 2 data sets here, as I mentioned. The first one is our study data set, and that's our source data from that US observational study. And that data set includes 6 variables: our outcome variable, our treatment variable, those same covariates and effect modifiers. And then we also have our target data set, and this is the data from the local population, also individual level patient data, and it includes information on the covariates and the effect modifiers. So 4 variables in that data set: sex, percentage body fat, stress level, and aspirin usage. So the first thing you're going to do is install Transport Health if you haven't already. There's another video that goes over that. And then we're going to load the packages that we'll be using today, Transport Health and Dippler. Here in this code, you can see we've also listed the different variables that are used in this analysis. That's just to make it easier to come back and revisit the code later. Now we're going to load in two different data sets. The first one is our study data set, and the second one is our target data set. I've saved them both in the R project folder, which makes it really easy to read them in. Now that they're both read in, we can check the number of observations. So we've got 1,000 in the study data and 1,500 in the target data. I want to look and confirm that there are no treatment or response data in our target data set. And we can see that there aren't any data on treatment or response. And then I also want to look at what's in our study data set and make sure that we have the same variables as well as treatment and response. Now we're going to use the Dippler package to combine the data sets. To do that, we want to add an indicator variable called participation to each data set. This will indicate whether a row of data comes from the source study or the target population. For a value of 1 is for the study data, and a value of 0 is for the target data. Then we'll want to look at the head of our test data to see what values are there. We'll be able to see that we have participation as our last column, but we want to make sure that we've actually merged the data successfully. So we'll look at our observations using sort of a cross tabs to see the number of values we have of 1 and the number of values of 0. These should correspond to the number of observations in each of our data sets. The last step before we get to the analysis is making our binary variables that we will use for plotting factors. This will improve the plots that we create. Now that the dataset is merged, we can perform the transportability analysis using the transport IP function. Here we've entered our MSM formula, our propensity model, our participation model, the type of MSM that we want to conduct, as well as our data frame. Using the base summary function, we can view the results of our analysis. This will provide the different coefficients, as well as a summary of the covariates and SMDs before and after weighting. We can then evaluate the positivity assumption by generating histograms of participation and propensity. This histogram shows propensity score by medication status. This histogram shows participation score by whether or not the participant participated in the source study. We can also evaluate the conditional exchangeability assumption by generating love plots of standardized mean differences, or SMDs, before and after weighting. Here we can see that after weighting, our SMDs are all close to 0. Lastly, we can generate plots of the transported effect estimate along with their 95% confidence intervals to summarize our overall finding regarding the estimate of the effectiveness of the treatment in our target population.